Okay, this is a video 1 on expected value. This is chapter 19 from the book. We're talking about expected value, conditional expectation, and law of total expectation in this particular uh, series of videos. Okay, so what exactly is expectation and why do we need it? If you think about the previous lecture that was on random variables, we saw how we could map each outcome. For example, for the toss of a coin, right? We were looking at heads and tails. Let's say I tossed it once. So if there is a random variable that I'm interested in, some measurable property, for example, how many times head appears by x, then I could map each outcome. Sorry, if x is heads, it has to be 1 and this has to be 0, right? So I could essentially map it to a certain range of numbers, right? It really simplified the way I expressed or I represented all possible outcomes, right? And then I came to the probability distribution function that better helped me organize all the possible probabilities associated with each outcome, right? So a random variable captured the entire experiment into probabilities of measured values, right? So it really made our life easier. Now, if we want to go a step further, and for any given experiment, we want to summarize it such that we can reduce this entire range of the probability distribution function to a single number that somehow characterizes what we expect to happen in terms of that particular random variable, which is a specific measurable property of the experiment, right? For example, one such measure is the average, right? We've been calculating average all along. And so one such property is the average of, like, let's say the total number of heads when I flipped a coin multiple times, right? So what is the average of getting a heads? So that really reduces my entire experiment to just one number that will characterize, okay, this is what I expect to happen if I flip the coin, let's say n number of times, right? So this is the high level idea of expectation, but let's look at it in detail. Okay, there is this is example where you have 20 independent rolls of a fair die and you're interested in getting the average value when you roll this die like 20 times. So what am I interested in is to get the average value, right? Okay, so there are two methods, obviously. As you roll this independent die 20 times, keep looking at the values that you get. So let's say I'm getting 3, 4, let's say 3 again, 1, 6, 2, 5, and so on. I don't know, like 20 times and 6, right? So method 1 is to simply go and add all these values, right, by the definition of average and divide by the number of these values. So for example, in this case, I'll just do a 3 plus 4 plus 3 plus 1 and so on up to 6, like whatever my die shows up, and then divide that by 20 because there are 20 rolls, right? So this will give me the average. Now another method could be that I group together the occurrence of each number. For example, I can group together, let's say I got like 1 4 times, right? So I group, sorry, this has to be 1, right? So I can group together these ones, and then some number of times I got the 2, so let me group together the 2, and then let's say I got 3 just one time and so on. Let's say I got 6 just 2 times. So I just group together all the occurrences of these numbers such that I can characterize the number of their occurrence by some integer that's like n1 is 4. So n1 is signifying the number of occurrence of the number 1. Similarly, n2 is 3, n3 is 1, and so on. I can get that number for every other number. And then n6 is 2 because 6 occurs 2 times, right? And we are interested in the average of the values that appeared on the face of the dice, right? So if I define that as the random variable that I'm interested in, which is the value that appears on the die, right? If I define that, so essentially I'm interested in the average of my x, right? Which I could have done like using this method, obviously, but I can also utilize another method, which is check the number of occurrence of each individual value, right? And then multiply by that value, right? So I can do that. Let me, I think I have, okay, let's write some of it here, and then maybe we'll have to continue the next slide. So this average can be rewritten as n1, which is the number of times 1 occurs, times 1, right? Plus n2 times 2, plus and so on, n6 times 6. And I know the number of, like, the total number is 20, so that stays, right? Now, we can interpret all of this in terms of probability, right? How? Because we know that if x is the value, if my random variable is the value that shows up, I can actually write down the in terms of my random variable when the probability of x equals 1 is actually n1 over n, where n is the total number of trials, right? In the language of probability. So total number of trials, right? Similarly, I can write down, and we know this from the knowledge of random variables, how we calculate the probability for each value that the random variable takes on would be n2 over n, and so on, right? So if we go back to our average equation, which we wrote in the previous slide, the average for x, this would nothing be but this, right? So I'm actually calculating probability of x equals 1 times 1, which is nothing but the value of the random variable for some x, which in this case is 1, right? So this here is that small x, right? Plus the probability of x equals 2 times the value that the random variable takes on when it shows 2, plus and so on until probability of x equals 6 times x6. So just like notice my random variable defined on for some x, right? So this is my x, right? This is how we used to write x equals x. Okay, right. So now we can generalize our experiment. We can generalize this idea of calculating the average by reducing this for like any n number of outcomes if we are interested in like a generalized experiment, right? So I can generalize this quantity or this entire like right hand side to be a summation for any given experiment, be a summation of x that's summed over all possible values of x in sample space S times the probability distribution function for x, which if you remember from the previous lecture was x equals x, and this is exactly what we are calculating in our average equation up there, right? So this average x here is actually defined as the expectation of x, or the mathematical expectation of x, or the expected value of x, right? And is denoted by e of x. Let's look at it here, right? So by definition, all the possible values x weighted by their probabilities, which we just saw, right? The probability distribution function for each value of x um, is given by this equation. This is the expected value of x. This is how it's denoted. So from now on, when we are asking you to calculate the expected value for a random variable, it should be like this, e and x, right? And either you call this expected value or expectation or mean or average, right? So those are some of the synonyms of this. But going forward, most of the time, we'll call it expected value. Okay, so with this, I end this video. In the next video, we'll look at some examples related to the expected value.